Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning program. I'm teacher Pasco, and today I will be with senior 4 students, and we will be working out the exercises for the end of unit number 5. The exercises we have are in two parts. We have the first part of multiple choice questions and another part of the structured questions. So without delaying, let us start with the first part. In the first part, we have 6 questions. So I want you to take your exercise books and a pen, and you will try to suggest the answer before we can discuss and give the right answer for these multiple choice questions. Which pair of elements reacts most readily? We have lithium plus bromine, lithium plus chlorine, and potassium plus bromine, and D, potassium plus chlorine. So which of the pairs do you think will react most readily? Will be more vigorous or the most vigorous when reacting? Remember how reactivity varies in the periodic table. And you should also remember how metals react and non-metals react. So I hope you're done. Now let us analyze the question. When studying the reactivity of elements, we should always remember that metals react by gaining and metals react by losing and non-metals react by gaining. So we have to analyze how the gaining ability or the losing ability varies in a given group. Why? Because here we have 2 metals which are in the same group and 2 non-metals which are in the same group. So how does reactivity vary in group number 1, the group of lithium and potassium? We said that metals react by losing. And as we go down the group, remember, ionization energy decreases. So it becomes easier to lose. So potassium will be the one to lose more easily than lithium. And if it is the one to lose more easily, then it is the one which is more reactive, because it requires a small amount of energy to lose the electron. And so suggestions A and B, which contain lithium, they are wrong. They can't be the one of those ones which will react most readily. So we choose from C and D. Now we have to check between bromine and chlorine which one has the higher ability of gaining. Remember, in non-metals, the gaining ability reduces as you go down the group. Why? Because the nuclear attraction is becoming weaker and weaker as the size increases. So chlorine is the one which will gain the electron more easily than bromine. So the combination of potassium and chlorine will be more readily than any of the 3 suggestions we have. I think that is clear. So the right answer is D. If you have suggested D, you got it right. Good. So we go to the second question. Which of the following properties of the halogens increase from fluorine to iodine? We have the atomic radius, melting point, and electronegativity. Is it the atomic radius only? You have to suggest the answer. Is it atomic radius and melting point, atomic radius and electronegativity, or all the 3? So think about it and suggest the right answer. which of the following properties, the properties we have here, of the halogens increase from fluorine to iodine? Some seconds and you suggest the right answer in your books. Hope you are done. Now, let us analyze the question. How does the atomic radius vary in the halogens? As you move down the group, the atomic size increases. We know that because we have more and more energy levels. And there is another way of explaining that. We know that screening effect increases more than nuclear charge, reducing the nuclear attraction, and then the size increases. So the atomic radius increases as you go down the group. But is it the atomic radius only? Let's remember what happens with the melting point. We've seen that as you move down the group, the atomic size increases. And we know from the last lesson we studied in this unit that melting point depends on the strength of intermolecular forces. So the intermolecular forces we have in the halogens, they are the van der Waals forces, which will increase as the atomic or as the molecular size increases. So as we move down the group in the halogens, molecular size increases, intermolecular forces become stronger, and the melting point increases, of course. So even the melting point increases. But what happens with the electronegativity? That measure of the tendency of attracting electrons. Of course, you remember that. It reduces as we go down the group because nuclear attraction is becoming weaker and weaker. So the electronegativity is not included. And because of that, the right answer is B. It is 1 and 2 only, which increase in the halogen from fluorine to iodine. So the right answer is B. A, C, and D are wrong, but B is right. I think this is very clear. We go to the next, okay? Rubidium is an element in the same group of the periodic table as lithium and sodium. So it is likely to be a metal which has, suggestion A, high melting point and reacts slowly with water. High melting point and reacts vigorously with water. Low melting point and reacts vigorously with water. Low melting point and reacts slowly with water. What do you think? Choose the right answer. You have some seconds. Like 30 seconds, it's very simple. You just check what happens with the melting point, and when you're done with the melting point, then you go to the reaction with water. The reactivity, of course, will depend on how easy the atom can lose the electron, depending on the ionization energy. So what happens with the melting point? From lithium to sodium and to potassium and rubidium, as you go on down the group, what happens? Does the melting point increase or decrease? We studied that in the previous lesson. As we go down the group, we said the atomic size increases, as well as the cation size. So the electrostatic forces become weaker and weaker. And as the electrostatic forces become weaker and weaker, then the melting point becomes lower and lower. So suggestion A and B with high melting point, they are wrong. So rubidium has a lower melting point than either sodium or lithium. We know that. And after the melting point, what happens with the reaction? As we move down the group, ionization energy decreases. So it is easier for rubidium to lose the electron than either sodium or lithium. So what happens? what happens is that rubidium will react more vigorously than any of the two, sodium or lithium. So which combination is right then? It has low melting point than sodium or lithium, and it reacts vigorously with water. So the right answer is C. The right answer is C. We go to the fourth question. Which property decreases down group 7 in the periodic table? We have 4 suggestions: the atomic radius, electronegativity, ionic radius, and melting point. The property which reduces as we go down the group, decreases as we move down the group of the halogens. Think about it. Some seconds and you write down the answer, and then we analyze the question and we give the right answer so that you can compare with what you have suggested. Which property decreases down group 7 in the periodic table? The atomic radius, electronegativity, ionic radius, or melting point? Good. Atomic radius. I hope you remember how the atomic radius varies as you move down the group. It increases. We have more shells, so it increases. So it is not the right answer. This one is wrong, because we are finding the property which decreases. Electronegativity. The electronegativity decreases as you move down the group. We know that. The attraction, nuclear attraction, becomes weaker, and then the tendency of attracting extra electrons reduces. So the electronegativity decreases. And I guess this is the property we want. Why? Because C and D are also wrong. We know that the ionic radius increases as we go down the group, just like the atomic radius. And melting point, we have seen this before. Melting point increases as we go down the group because the intermolecular forces become stronger. So the right answer is B. The right answer is B. I think this is very clear. We go to the next. We have a potassium atom has a larger atomic radius than a sodium atom. And which statement about potassium correctly explains this difference? We have 4 statements. It has a larger nuclear charge. It has a lower electronegativity. You think about it. It has more energy levels occupied by electrons. It has a lower ionization energy. And which statement, the statements we are suggesting here are to explain why a potassium atom has a larger atomic radius than a sodium atom. So which statement will explain better that difference? Think about it, and you write down the answer. It has a larger nuclear charge. How does the nuclear charge affect the variation of the atomic radius? We always expect a decrease in atomic radius when the nuclear charge is increasing. So a larger nuclear charge cannot explain why potassium has a larger atomic radius than a sodium atom. It has a lower electronegativity. The electronegativity cannot influence the atomic radius. And C, it has more energy levels occupied by electrons. What happens when the number of energy levels increases? When the number of energy levels increases, we know that the atomic radius increases too. So this is the right statement to explain why a potassium atom has a larger atomic radius than a sodium atom. Of course, it cannot be because of having lower ionization energy. So the right answer is C. And the last question of the multiple choice questions is, which statement is correct for a periodic trend? Which statement is correct for a periodic trend? A, ionization energy increases from lithium to cesium. B, melting point increases from lithium to cesium. C, ionization energy increases from fluorine to iodine. And D, melting point increases from fluorine to iodine. So which of these statements is correct for a periodic trend? You think about it, please, and you write the suggested answer down, and then we will discuss and analyze which statement is right. For a periodic trend, which statement is correct? Ionization energy increases from lithium to cesium. What happens in a given group as we move down the group? Does ionization energy increase or it decreases? We know that it decreases. We know that. So as it decreases, then this statement is not right, is not correct for a periodic trend, because it is actually the opposite of what happens. B, melting point increases from lithium to cesium. That is not right. We know that it decreases down the group, so the statement is not correct. And C, ionization energy increases from fluorine to iodine. We know that it decreases down the group because the size is increasing, so it is easier to lose the electron. And D, melting point increases from fluorine to iodine. We know that. Intermolecular forces are becoming stronger because of the molecular size, which is also increasing, and then the melting point increases from fluorine to iodine. I hope it is very clear. And now let us go to the second part. Part B, we have structured question. A, define the term electron affinity. What is electron affinity? Write down the answer, please. Electron affinity. Electron affinity. Okay? So we have seen that electron affinity is the energy change which occurs when 1 mole of gaseous atoms gain 1 mole of electrons to form negative ions. And number 2, write an equation including state symbols for the process occurring when measuring the first electron affinity of aluminium. So you use aluminium and you write the equation representing the first electron affinity of aluminium. Don't forget to include the state symbols. Good. So the equation is we have aluminium, which must be in the gaseous state, plus 1 electron. Remember, The electron affinity is the energy change when an atom gains. Okay? So it is gaining 1 electron, and we get aluminium gaseous negative, 1 negative. That is the equation representing that process. And B, we have some ionization energies of sodium and magnesium are shown below. We have the values here. First ionization energy, second, third, and fourth. For sodium, it is 494, 4,660, 6,940, and 9,540. For magnesium, 736, 1,450, and 7,740, 10,500. And what are the questions? Here we have the questions. Explain why the first ionization energy of magnesium is greater than that of sodium. How does ionization energy vary as you move across any period? We know that it increases. But why does it increase? It's because the atomic radius decreases as the nuclear attraction becomes stronger. And then it requires a lot of energy to remove the electron. So that is the reason. If you have taken a summary of what we studied previously, you can find the answer in your summaries. And if you didn't get that chance of taking good summary of what we studied, you can go on the e-learning portal of Rwanda Education Board. We have a book of Senior 4 Chemistry. You will find some notes there giving the answer. And then sub-question C, sodium reacts with water. Write an equation for the reaction and state 2 observations that could be made during the reaction. What is the equation? We are on C. Sodium is reacting with water. What happens when sodium, solid sodium, reacts with water? We produce sodium hydroxide and hydrogen gas. Sodium hydroxide and hydrogen gas. And the 2 observations that can be made: sodium floats on the surface of water. And what does this mean? This means that it is less dense than water. And the other observation is that it produces a hissing sound. Produces a hissing sound. And state the meaning of the term electronegativity. What is electronegativity? Electronegativity means a measure of the tendency of attracting the electron pair towards itself in a covalent bonding. And state and explain the trend in electronegativity down group 1. We remember that. Down group 1, electronegativity, how does it change? It decreases as we go down the group because the size is increasing, and then the tendency of gaining electrons reduces. Explain why chlorine rather than bromine would react more vigorously with a solution of I negative, the iodide ions. Think about it. It is because chlorine is more electronegative than bromine. So it has a greater tendency of attracting electrons than bromine. What is first ionization energy? Do you remember the meaning of first ionization energy? The energy required to remove the first electron from gaseous atom. And we explain how it varies in the periodic table. Do you remember how it changes in the periodic table? Down in a group, it decreases because the size is increasing. And across the period, it increases because the size is decreasing. But remember the two exceptions we have in group number 2 and group number 5, because the first electron is removed respectively from a full orbital and a half-full orbital, which are very stable. So it requires a lot of energy to remove those electrons. And explain how the first electron affinity varies in the 7 group 7 of the halogens. As in any group, it decreases because the size is increasing. But why did I ask group 7? It's because in that group we have an exception. On fluorine, there is an exception. And the exception is because of its very small size, what creates a strong shield for the incoming electron. So that is the end of today's lesson, the exercise lesson, and here we have the homework. And here I would advise you to take photos because we have it's like we have many questions. So it will be easier if you can find a smartphone and then you take a photo of this. So you take a photo of this first slide, and when it's done, or if you can copy the exercise very quickly, then we go to the next slide. And here we have the next slide. I don't think it will be very easy to draw the graph, so please find how you can use your phone and you take the image. It will be easier, because these are very good exercises. You have to try to make sure that you have understood what we have covered in this unit. And this is the last slide of the exercise. You can also take the picture. So thank you very much for your attention. See you next time.